Hello everyone, my name is Guilherme Bastos. I wrote this article and some friends of mine and also some people that I don't know, they requested me to talk about it a little bit more and also to do some test case for this formula here. So first of all, let me introduce you the topic, okay? So you can see this on my LinkedIn. Uh, my name is Guilherme Borges Bastos. You can check there, and you can also check the repository itself in my GitHub account. The repository name is called an anti-traversing to the array. So let me introduce you to the topic. So imagine that you have, so this is something that, this is a challenge that I have faced recently. So let's say that we have a matrix, okay, a bidimensional matrix of 8 columns and 3 rows. This is a very small one, just in order to make our life easier to do to correlate things here, okay? So okay, and there's also a logic that a specific logic for numbering each symbol on the board. So each element from the board has a specific numbering. Okay, so if you overlay both matrices, we would have this. So as you can see here, the logic position 0 represents the letter A. Okay, so 0 here represents the letter A, and its pair index, it's just the at row 0 and column 0, okay, which makes sense. And for the 8 is the same. As you can see, the logical position 8 represents the letter J, and the pair index, it's the row 1, as you can see, the second one here, and is still in the first column, so that's why it's 0. And the same for the letter for the position 16 that represents the letter R, and we have as its pair index the row, the third row, that which is 2 in the array here, right? In the third row, but still the first column. That's why it's 0 here. The same logic can be applied to any of the elements. So it doesn't matter which one here, they are still respecting this logic. Okay, so first I was wondering here, okay, so how could we retrieve the value of any element from the board based only in the integer position, okay, of each element on the board? So let's say that I sent to a method the integer value 23, and I want to have as the output the letter W. Okay, so our first thought, at least my first thought, was to traverse the 2D matrix until reach the expected logical number, which isn't good regarding the performance because, as you can see, the complexity here increase according to the size of the matrix itself. So this is not good. So as you can see here, I'm checking for every row, I'm checking every column, and then I do that till reach the expected logical position. After that, I retrieve the element, which is not good. Okay, this is going to work in our case because it's pretty small, but as you can imagine, as this matrix grows in size, we will have problems with the performance. Okay, so as you can see, I have requested the logical positions 0, 8, and 16. As the output, I have the letter A, the letter J, and the letter R. Let's double check. 0, 8, 16 represents the letter A, J, and R, which is okay. Okay, great. But hey, wait. I think I could improve that. So at this point, when I was developing this exercise, I tried to find a formula in the internet or something, or some people discussing about that. about how could I retrieve the value of any element into a bidimensional matrix without uh, the need to traverse this matrix. And I wasn't able to find this, so I decided to analyze the data. I have decided to analyze the relation between the integer logical position of each element on the board. So what's the relation between the number 7 and the column and row that represents this element on the board, on the matrix? So that's when I did this guy here. So after doing some tests, I wrote for every single guy here, I wrote, I tried to make a map, I could say, I guess, and I found out that we could have a relation between the position, the logical position integer, and the row and column itself. So this first formula here, it doesn't work because it was working fine, but just for odd metrics. Okay, so even metrics, it wasn't working as expected. And I was a little bit frustrated at the first time, but I kept trying, and finally I was able to find the correct formula. Okay, so let's continue here, and I'm going to present to you the formula. So as I was saying, what would be the formula to retrieve an element from the board without iterating over the matrix itself? So based on the logic that enumerates each element on the board, this is very important to emphasize, because depending on the logic here, the formula is going to change. I have the formula for both for this kind of numbering logic here that starts asking from the first row, for example 0 here at the very left in the first row, and ends in the very end of the first row with the number 7, and in the next row we will have the integer number. So I have the formula for this one, and I also have the formula for this one, where it starts at the top of the column and ends at the bottom of the column, and then it goes to the next column. Okay, so it's a different way of numbering, but for each one I have a separate formula which is working fine. So if you need this another one, I have also, but let's focus in this one which is more common. Okay, so like I was saying, let me quickly explain to you the formula itself. I wrote here a quick formula explanation, which I think it's pretty straightforward. The element, as you can imagine, represents the value placed on the matrix. So let's say the letter A, letter B, C, and so on are the values that the element represents. So the element is what I'm looking for, based on the logical position, okay, of each element on the board. So that's clear, I guess. The X here represents the coordinate or the integer logical position of each element on the bidimensional array. In our example, it's a range of 0 till 23. Okay, in our case, it's 0 till 23 because I have just 8 columns and 3 rows. But it could be any other size. It doesn't matter for this formula, it's working. Okay, so let's talk about this one here. This is really simple, as you already know. This array 0.length represents the length of the columns. Okay, so in our case here, as you can see, we have 8 columns. Okay, so this is going to be, in our example, 8. Also, in this another one, it's 8 as well. Great. The row here is a simple division between the logic position that's represented by the letter X in our formula and the array's column length. Okay, so this one is the output of this of this logic here, of this arithmetic calculation, is going to be the integer that represents our row, okay, in our bidimensional array. And the modular result of the arithmetic calculation between x and the length of the columns represents our column itself. So let's do a quick example here. So let's say that I want the 23. So let me take here a text document, just in case. Okay, great. So let's get a little bit down here. Okay, so I want the 23. Great. So 23 is my logical number that I'm looking for. So let's inject this 23 into our formula and see what we have. So let's right here, let's first start from the row. So 23 divided by 8, okay, so it's not going to be an integer there. It's not there's something remaining, right? So it's going to be in Java 2. Okay, so 23 divided by 8 in Java, we are going to end up in the integer 2. So let's find out. So better, let's continue here. So let's go to the next one. Great. So let's 23 again, that's our logical position, modular of 8. So as we know here, the 8 is not going to fit more than 2 times into 23. Okay, so 16 less 23, we are going to end as 8. Oh, I mean, my bad, as 7. Terrible math, as I said. Great. So let's check. So I was looking for the 23. So the 23 we know, which is the last one, it's equal W, right? So let's check here. Okay, so let's start from the row. It's the third row. First, second, third. Okay, we are good here. Now I know that our value is somewhere here. Now we also know that the column is the column 7, which is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so as you can see here at the column number 7 and the row number 2, we will find our value without the need of traverse the matrix itself. So this is the basic functionality of the formula, but as I said, I wrote several test cases here in order to make sure that this is working as expected. I do that in a vertical selection, horizontal selection, diagonal selection, and so I made sure that this is really working, and not just for, we have different dimensions of matrix here. As you can see, we have 3 rows, 8 columns, we have 2 rows, 5 columns, 4 rows, 4 columns, we have also 3 rows, 3 columns, and so on. So we have several different combinations here, just to make sure that it's working. Great. So okay, so finally I have applied these. Forgive me for the names. I'm terrible with the names, by the way. But here is the formula, which you can see that the implementation itself, it's much cleaner, and of course the performance here, it's much better, because now the complexity of our code is going to be a constant time, which means doesn't matter how many items we have in our matrix, the time response for this code is going to be in the average the same. Okay, Okay, so as you can see, and you can also double check if you clone this repository or you fork this example, you can see that here is going to output the same letter A, J, and R as we were expecting based on the logical positions here. So this is working fine. So what's the conclusion from this one? Guys, as I said, I'm far away from a mathematical guy, okay? But I really would like to have your opinion about it. And as I said, I hope this can be applied to some real life applications. That's something that I'm going to bring to the company that I'm working for, and also to my personal life as a developer. And as you can see, as I said, there's no one size fits all, of course, mainly in the IT sector. But I can guarantee that there's always a way to find the relation between the matrix and its coordinate, its logical position, which could save us a lot of processment and which could make our applications much cleaner regarding to its implementation, but also much faster, which is what I really want here. So guys, please send me links about the articles. If you already saw these somewhere else, please let me know. I really want to see if this is something that is new or not. Please help me do some research, send me books, articles, whatever you have. Please help me to dive deeper on this subject. And please, double check for yourself. As you can see here, the unit tests are working fine. As you can see, it's working okay. And I would like to have your opinion about it. What do you think? How could we improve that? How could we apply this in some scenarios? Is it something that could help you currently on what you are doing, or is it useless, or what do you think? Please let me know and let's talk. Thank you very much.